Okay, so can you see the presentation?
Yes.
And can you hear me okay?
Yes.
Okay.
Yes.
So this is my presentation that I did on steganography. It was just a presentation to kind of bring some like the research to help share to people like what steganography is and how it's used in the cyber world, both for protection and also used by threat actors, and how we can help prevent some of the malicious intents of steganography. So to start off, bringing over kind of a overview of what steganography is it's somewhat compared to cryptography and encryption, and the main goal of steganography, or the kind of point of it, is it's somewhat of an art of hiding a message within another message or medium. So you can do this by using any kind of medium you have, whether it be a digital, or there's even some physical real world applications of steganography where people have a painting and inside the painting there's a hidden message. And once you know to look for it, it's easy to find and it's easy to read. It's plain text, but the point of it is so that you don't realize that there is a message there. The goal of steganography is to hide that there is even another message behind the original one. So that way you can send this message and you don't have to hide that there's being something sent. You just have to hide what the true message underneath is. One of the kind of original or claims of where this kind of originated is from the Romans, where they would shave a messenger's head and tattoo the message. And once the hair grew back on the messenger, they would send them off. I don't know the exact truth behind this or where the real source of this comes from. To me, it seems a lot more work than necessary. I think part of my concern is also if you get a tattoo artist that doesn't know how to spell, you might get a little bit of an awkward ending. Um, and then some of the common versions of steganography now is using a picture and then hiding a message or another file using the least significant bits of the pixels in that image. So here I kind of have an example using a picture of my pets. And you can see on the left, I have the original image where it's just a normal picture. And then I used a steganography software, which I'll go over in just a second. And I took this text document that just says hello, and then it's been steganographically hidden inside the image. And now the output image is on the right. And to the human eye, it looks completely the same image. Like you can't tell any kind of difference. It looks just the same, but there are subtle differences in the pixels. And you can see that here, where on the far right image now, where it's kind of a white tinted, you can see these little red pixels, and each one of those red pixels is a difference in those two images. Using a online image comparison tool, I took the two images and compared them so you can see how the images are different, so that you can see each pixel is spread across the whole image, and it's very little that needs to change. Then the tool I used was called OpenStego, and you can see that in the bottom left. There's two images where I have the way it's used to hide the data and how you can extract the data. The left picture just has you have a message file, which is whatever you want to be hidden in the image. In this case, it was just text.txt. Then you have the cover file, which in this case was the capture.png, which is the picture of the dog and cat. And then you tell it what you want the output file to be. So it'll be the same type of file as the cover file, but it'll have that additional message hidden within it. And then you can do encryption with steganography, but it's not a necessary kind of part of steganography. It's not built into all steganography tools. It's just built into some, and a lot of them will offer the ability to encrypt your data as well. And then for outputting or extracting the data, you just choose the image that's supposed to have the hidden data inside of it, and then you tell it where you want the folder, or what folder it should be outputted to. And if there is an encryption password, then you would include the password. So some of the uses of steganography is that is in general, you can just if you have a message that you want to be sent to someone, if it's maybe you have reason to believe that someone's watching your communication, if you have someone that you know already knows the way to undo steganography, then you can be sending them images of just cat memes or something like that online and then hide the real message in that. This can also be used in a way if you want to hide data on machines or networks or anything like that, by using just images as some storage on your network or device. So that way, if someone was to get access to it, then they would just see images of random things or just random files that don't seem to be important. This isn't really recommended and definitely should not be used as a main defense. It's more of just an addition thing if you want to kind of add some hiding. Then as well, steganography has been used for detecting who leaks a document in some cases. So if you're working on, for instance, a movie and you have all these digital scripts, you might use a digital or steganography watermark on each version of the script and send out different put on different watermarks to different versions. So if you have John and Jane both working on the movie and you both give them their own steganography watermark, then you could know who releases it by going and finding that document online if it gets leaked, and then undoing the steganography watermark to see who originally was supposed to have that version of the script. Other versions of steganography can also include just using audio as a cover file. Even just changing file type can also be counted as steganography, although it's very easy to detect. You can also use a text file, but since a text file is so small, it makes it difficult and you can only hide so much. On the right, though, I do have a kind of depiction of the way steganography is, how you can kind of visualize it as it's a umbrella term, and there's a lot of different versions underneath it. You have digital with like image, audio, and video, or you have linguistic types. So some of the more malicious applications as well for steganography could be trying to extract data out of a company. If you're inside and you're an employee, sometimes employees will use steganography to try to get around data loss prevention tools so that if they can send out an image in their email, then maybe it can send out some other things. So that way, using steganography is definitely an option, and you want to try to check that to make sure that if you're trying to protect your company, that no one else is using this. Malware has also been hidden using steganography in the past. And I actually have kind of an example on the next slide of showing how that can be done, because the Ocean Lotus APT group has used steganography to hide malicious code in an image, and then once the victim downloads software, it will go out online and download the image with the malicious code on it, and a lot of antivirus wouldn't detect that it was hidden within that image. So here's kind of a depiction of how that might work, where you have a phishing email, and then you have an employee that clicks on whatever it is, and it downloads this file or this malicious code. Or I guess this code wouldn't itself be malicious. It might just be to an antivirus, it wouldn't look malicious, but it would then download an image from some image hosting service, and that original program that was downloaded on the computer from the phishing email would then extract the steganography code from the image, which then is a malicious code, but at that point it has already gone around the antivirus since it's already been downloaded to the system. So for detecting steganography, it, depending on how complex the steganography is, can depend on or can choose make how easy it is to detect it. So if you have a image, just a plain colored image, then it's easy to detect that there's pixels that are changed. Also, there's more advanced versions of steganography software out there that will help um, hide the data in more complex portions of the image. So if there's an image with a lot of shadow area where pixels already are changing a lot, some steganography tools will hide the data in that area where the pixel's already changing a lot. One of the ways you can also make it more difficult to detect is by getting rid of the original medium that the message is hidden in. So for instance, the way I was able to show how steganography was used in my example was by comparing the two images. But if I had gotten rid of the original image, there would be nothing to compare those pixel values to. Using the size of the file can also help detect steganography. In some cases, what the file type you're using, the steganography tool might just add on additional data to that file, which then might make a text file that is a lot bigger than a text file was supposed to be. There's also some uses of machine learning trying to help detect steganography by looking at things that it's supposed to determine when a file is unlike what it should be from what past values they have seen is. And then in this slideshow, I also included another somewhat example of steganography. So on the first 5 slides of this slideshow, there were lowercase letters in the titles of the slides to spell out the word hello. And here are my resources that I used to create this research and presentation.